What I need you to do is note the statement that's on the screen.
Now, it's supposed to be WebEx recording.
All right, so everybody has ports, interfaces that share the same route and link or broadcast segment will be on the same network. All right? Okay, with that in mind, let's take a look at a diagram. How many networks do you see there? Well, remember our rule about interfaces, networks, and same router? If we look at this particular router, we know this router is associated with how many networks? How many? How many? How many cables are connected to that router? Each cable is going to be a network. So in regards to this particular router, which is router 1 has 3 networks. This is one. This is one network. Network number 2, network 3. Okay. All right. And note the address space at the top of the diagram. 200.200.200.0/24. What's the dotted decimal subnet mask? 255.255.0. Okay, let's assume that our ISP has given us this particular address space. Okay, well, we've got to spread this address space across the networks that we see on the screen. So that's going to require us to do subnetting. And if we recall the subnetting steps that are posted in Moodle, step 1 says determine the required networks. So we have to look at the diagram and figure out how many networks are before us. How many networks are there? Okay. We've already said that this is 1, 2, 3. Okay. And now if we go back to the previous statement, ports interfaces that share the same routed link or broadcast segment will be on the same network. Then we can determine that this router and this router, that's router 1 and router 0, share a network because the interfaces are on the same broadcast segment. So let's start counting the networks again. 1, 2, 3, 4. Okay, and I want you all to complete the count. How many networks did you come up with? Okay. Okay, John said 6. Did anyone get 7? Okay, let me count again. Okay, let's start from this side. 1, 2, 3, 4. Did I make a mistake? What was the mistake? I counted those interfaces. Those interfaces are part of the same network because it's shared. Okay, we don't count these links, right? Because only routers create networks. So both of these links are in essence associated with this particular link or broadcast domain. So it's 1, 2, 3, 4, 5, 6. All right. So just remember that routers separate networks So if there isn't a router that's separating the link, then you don't have multiple networks there. Okay? So switches don't separate networks. So we could have 1,000 links associated with this particular switch. 1,000 links will be a part of the same network. Okay? Okay, so we need to do some subnetting, and step 1 says determine the required networks, and we've determined we have how many networks that we have to satisfy in terms of host addresses? 6. Okay. Then step 2 tells us determine the least n value of the 2n formula that satisfies the above requirement. Okay. So 2n, what is n that will satisfy at least 6 networks? Okay, John says 2 to the 3rd power. Why not 2 to the 2nd power? Yeah, 2 to the 2nd power will give us the value 4. 2 to the 8th or 3rd power will give us 8 networks. But that's too many. We need 6. We don't need 8. So can we do something a little differently? No, we can't. So we have to go with. In this instance, we have to use the value 3. It's going to give us at least 6, a little more, but we can't use 2 for n in this instance. Okay, so let's do some subnetting. All right, we start with the original /24. Okay, since we determined that n is 3, then we know that we need to borrow how many host bits? We need to convert at least 3 host bits to network bits. Okay? All right, so the original demarcation would have been here. Y'all agree? Okay, since we need to borrow 3 additional bits, we need to start by selecting the 128-bit, the 64-bit, and the 32-bit. I'll go ahead and highlight the 32-bit. And this indicates that this line here is now the new demarcation. And this demarcation is separating what? Host bits from network bits. Okay? All right, we need to calculate the new subnet mask, which is step 4. What's the new subnet mask? So we're using 27 ones, right? So the first 8 will create 255, the second 8, 255, the third 8, 255, and what about the last octet? 224. All right. Now we have to get to our method of calculating the subnet. So we need to start with the lowest possible combination in terms of borrowed network bits. And that's going to present what value or what combination? 3 zeros, right? Okay, at 3 zeros. Okay, to determine the network address for the first subnet, basically we're going to start with the first octet, second octet. We know the first 3 octets won't change because we're only manipulating the 4th octet. To determine the network address of the 4th octet, or the value of the first or the 4th octet, we need to assume that all of the host bits are off, right? From last session, we mentioned all zeros in the host portion equal network address. Okay. So we get 0. And how do we determine the broadcast address. We turn on all the host bits, right? Okay. And then we start calculating the first octet, second octet, third octet, and the value of the fourth octet. We're basically going to add up all of the bits, and we get 31. Okay. All right. We found the first subnet. Now let's create the second subnet. How do we do that? Again, we start with the borrowed host bits, and we go to the next least combination. Okay, and Keith says it's going to be 32, right? So it'll be 0, 0, 1. The network address 200.200.200.32. Because we assume that all of the host bits were zeroed. Now we have to create the broadcast address, 200.200.200. How are you getting 63, Camille? Oh, you're adding the 31 host value to the network value. 31 plus 32, okay. So we get 63. Okay, we'll go ahead and to the next subnet. What's the next least combination? Okay, 0, 1, 0. Hey, we ended the previous subnet at 63, so we know the next value is going to be 64. Okay, what's the broadcast address for this subnet? $95? Is that all right? Okay, and what's the next least combination in terms of bar network bits? What is it? Put a 1 there and make it 128. Okay, why would we go from 95 to 128? Okay, if the previous broadcast address is 95, then the next value is going to be what? 96. So how do we create 96? So it's going to be 0, 1, 1, 200.200.200.96. And then we know the broadcast address is going to be 96 plus 31, which gives us what? 127. Because we've established a pattern here. We're going in increments of 32. All right? Okay, what's the next least combination? 128. Okay, and then when we get here, it's going to be, 128 plus 31 will be 159. Okay, then the next least combination is going to be 160, right? How do we create 160? Okay, 128 and 32. Okay, and then our broadcast address. Yeah, 160 plus 31, 91. Okay, and what's the next least combination? 192, so there'll be a 1 here. Okay. And what's this value going to be? Okay. Why could it not be 222 or 224? The broadcast will always be an odd number. All right, and what's the next least combination? 224. How do we treat 224? It'll be 1, 1, 1. You notice we've maxed out the borrowed subnet bits or network bits. That tells us that we've completed our subnetting process. We can't go beyond this row. Okay. What's the address for this row? 224. Okay, and the broadcast is going to be easy, right? All ones, that's 255. Okay. All right, now let's apply this to the diagram. This particular interface, which is E1/0. Okay, I'll turn on the interface so we'll get a green light. Okay, what's a good IP address for this particular network? Go back to the chart. Do we have to start with the first network? No, we can start here if we want. Okay, let's start there. What's that? Need to keep a pattern, so we'll start with the, okay, we can start from the bottom and work our way up. All right, so help me out. What's a good IP address for this interface, which will also be the default gateway for the local area network? 225, and what about subnet mask? 224 in the last octet. Okay. All right, we're up and running there. Okay, we need to address the hosts, the end devices. Okay, we'll start with this PC. 200.200.200. Can I use 245? Yeah, because it's within this range here. I can't use the 224 and I can't use the 255. Yeah, I can use. Yeah, 224 is the network address. Okay, can I use the subnet mask? All right, what's the default gateway? What is it? The default gateway is 225. It can't be 224 because that's the network address. All right, let's do a connectivity test. Okay, good to go. All right, and next PC. $226, okay, and make sure we have the right subnet mask and the appropriate default gateway. Okay, what should I do now? Yeah, connectivity test. the other PC, and we'll check the default gateway. Good to go. All right, now let's configure the printer. IP address is, what's a good IP address? Can I use 250? Yeah, sure. If I can use 250. Okay, am I done? Subnet mask. Okay, am I done? What about default gateway? Because PCs on a different network within our organization may want to access this printer. Okay. All right. Let's ensure we have connectivity to the printer. Okay, good to go. All right, we've completed the first network or subnet. Okay, let's go on to the next subnet. Okay, let me see what interface is associated with this network. It's E1/1. Okay, what's a good IP address? Okay, we're starting from the bottom and working up. 193. Okay. Okay, subnet mask is right. Okay. Can I use 195? Yeah, it's within the range. Okay. What's the default gateway address? 193. Let's do a connectivity test. Good to go. All right. Let's configure another PC. What do I have? Can I use 220? Let's see. I'm dealing with this row, so yeah, I can use 220. Okay. Okay. 224. Okay, connectivity tests. Okay. Okay, we want to ping with inside the local area network first and make sure we have connectivity. Then we could try outside. Okay, let's try the printer. And the printer was 250. Okay, there we go. Okay, we talked about the timeout briefly last class, and we'll get more into that later. That had something to do with the ARC process, address resolution protocol. All right, let's go to this particular interface. This is a serial interface. Note that the cable's a little different. And serial interfaces are basically used for WAN connections, and we'll talk more about those in a later chapter. Okay, but this is a different network, right? Because it's a different interface on the same router. All right. What interface? It's S020. So I need to find S020. What's a good IP address? 161, okay. Okay, good subnet mask. I need to activate the interface. Okay. 161. All right. What's next? I need to go to the other side of the link. And I need to configure, let's see, it's S020 of router 0. Okay. S020. What's a good IP address for this interface? It's the same network, but we can't use the same host address. The host address must be different. We have 162. So we can never have duplicate host address regardless of the situation. Okay. Am I done? 224. All right. So what should I do now? Do a connectivity test. Okay. Let's see. There we go. 5 successful pings. Let's see. Let's look at this routing table. All right. I see the 160 network. That's directly connected. We see the 192, the 224. The printer is associated with the 224, right? So we should be able to ping the printer because the router has an address for it. It has a network address for it. Question. Okay, so we need to, let's see if we can ping the printer. Yep. 5 successful pings. Okay, now we need to deal with this particular link, broadcast segment. So we need to configure F0/1. F0/1. All right, what's a good IP address? Let's go back to our table. We've used the 224, the 192, and the 160 network, so we'll move to the 128 network, and be 129. Subnet mask is good. Okay. All right, we have green light. Let's configure some PCs. $130, is that okay? Ah, someone called it 224. Okay. We'll just do a connectivity test. Good to go. Okay, what's a good value? Can I use 158? Yeah, because max is 159. What's the default gateway? 129. Let's do a connectivity test. Oh, come on. Okay, we got the default gateway. Let's try the printer. We got the printer. Okay, let's do a little housekeeping. Let's put a label, or let's label the networks so we can kind of keep track of our subdivided address space. Dot 200.200.0/27. So we know that this network here is the 200.200.200.0/27. Is that correct? No, that's not correct because we started with the 224. All right, so that's the 224 network. And we're building a diagram. In your organizations, you'll do the same. Okay, so if ever some troubleshooting is required, it's easier to look at your little diagram or roadmap and your dissecting efforts of locating the problem. Okay, what network is this? 200.200.200.192. Okay, and what's the subnet mask? /27. Okay, we see the benefit of using the slash notation or the shorthand. If we didn't use the shorthand, we'd have to type out all those additional digits, right? 255, 255, 255, 224. Okay, and what was this network? 200.200.200.160/27. So it's 200.200.128/27. Okay, now we need to go ahead and configure this link. This is a fiber link, but because it's it's a different interface, it must be a different network. Okay, let's see. We have, it looks like F1/0. Okay, and what's an appropriate IP address? We're dealing with the 96 network now. So we can configure anything with a value of 97 through 126. Okay, so we need F1/0, 200.200.200.97. You had a green light? Yeah, you can get a green light if you activate the interface, but it just won't communicate. Yeah. Okay, all right. We need to go to the other side of the link, and that's going to be F1/0. Okay, and what's the good IP address? 98? Why 98? They share the same link, so they must be on the same network. Okay? Okay. Right subnet mask. Now, how many host address are there available on each network? How many? There's 5 bits available, right? 5 host bits. So we do 2 to the 5th power gives us 2 to the 5th power. 32 minus 2 because we can't use the network and broadcast. So 30 host addresses, right? Now, this is one network, and how many possible hosts can be on this particular network? Only two, right? This interface and that interface. So we're wasting 28 addresses on that one network. So as we go along, we're going to come up with a different process. It's called a variable length subnet mask, where we can subnet, but each subnet can have a different subnet mask. Okay. All right. Are we done here? We need to do a connectivity test, right? Let's do a connectivity test. Okay. Let's see what's in the routing table. Okay. All the printer network is there, right? It's 24 so we should be able to ping the printer. You're probably wondering, how is it that these routers are able to communicate with remote networks without statically assigning networks or programming those networks in the router? That's because prior to class, I programmed a dynamic routing protocol to kind of simplify the process. Hence, if you look at the routing table, you see those R's there. Those R's indicate that RIP routing protocol is running. Okay? And the R's indicate that this particular router learned about the remote networks via RIP. Okay? Let's do some housekeeping. Let's go ahead and label this network. What network is this? 96/27. All right. One more network, and it's going to be the 64 network. And let's see, we need to configure F0/1. .65, turn on the interface. Okay, program the server IP address, 200.200.200. And we'll make it the highest in the range, which will be a 94. Okay. What is the default gateway address? Yep, 65. Let's do a connectivity test. Start inside first. Okay, we can ping the default gateway. And we know that the default gateway router knows about the printer because we just saw that routing table. So we should be able to ping the printer. And we can. All right. Okay, one more PC. What's the default gateway address? 65. Okay, am I done? I'm seeing some shaking head. What's wrong? The IP is wrong. Okay. Now, if this were an actual Windows machine, we would have gotten an error, right? Yeah, because the IP address, or the host address, and the default gateway address are on different subnets. So what's the appropriate host address? We can't use 65 here because 65 is the default gateway. We can use 66. Okay, let's do a connectivity test. Good to go. All right. Am I done? Oh, we need to do some labeling. 64 network, right? All right, let's go back to the subnetting chart. So we have 2 spare subnets. So if at some point the organization acquires or establishes different additional departments, then we have 2 additional subnets to address those. So let's see what type of capability this router has in terms of creating additional networks. Is there a disadvantage of having 2 additional networks? It depends on the situation. Let's say that we've concluded that at maximum on any of these subnets we can have no more than 30 hosts. Let's imagine that we have a network in the future that requires more than 30 hosts. And we're going to have to do something different. So that's when we'll get into variable length subnet math. Okay. Again, let's see what interfaces are available on this router. Okay. Note what I'm doing. I'm looking at F1/0. It's used. F0/1 is used. F0/0 is available. Well, let's assume that we need to establish 2 more networks. So we can't do it with this router in its current condition. We have to add an additional interface, right? Mm-hmm. So we'll turn off the router and let's go to, okay. Yeah, this is an Ethernet module that will fit in one of the smaller bays. Okay. So now we have an additional Ethernet port. So if we wanted to, we could get some more switches. Cables. Okay, there you have it, 2 additional networks. Okay. All right. As I said at the end of last session, the variables may change. For example, you may need additional networks or less networks, but the process will be the same. Okay. Until we get to Class B, Class A, and variable and subnet math. Okay.